Hi, good morning, good afternoon, and good evening, everyone. Today is day two. So let me share my screen. So today we will see the lab setups options for to build your own labs, and also we will see what is inside the IP header. We'll see that in Wireshark, different types of packets, and we will do a lab for it. To start with, let's go through the layer two frame. So we say this is a layer 2 frame. We all know this. We mostly use this. We know this. What is source MAC? What is destination MAC? But something the additional fields we never looked into. Maybe few people's they never looked into is ether type. That tells a layer 2 that what is the next protocol I'm going to see. Is it an ARP? So mostly it is an ARP or IP. That's something in the ether type field you can see. Then if you look at this, if I say the Ethernet header, if you calculate this 6612 plus 4, 16, 18 bytes of data is your Ethernet header. And this a complete payload is 1500 bytes. It cannot exceed 1500 bytes. So that's why the layer 2 MTU is 1500. It cannot exceed beyond 1500. There is no fragmentation happens in Ethernet header. And Wireshark, if you see, it doesn't calculate your FCS or CRC errors. So it's purely with the hardware, and the hardware should actually do that. And that's why you can see that in the actual NIC, in the every port of the switch, if you give a show interface, you will see the CRC. But the Ethernet, sorry, the Wireshark cannot interpret or decode any information related to CRC. So what we can see in the Wireshark is destination MAC, source MAC, and your if there is any VLANs added, and if it is going through the switch, you can see those VLAN packets, VLAN IDs, sorry, and then the ether type. Is it an ARP or any other ether type? It's being used. So this helps us to troubleshoot when you are doing something like a ping to a destination, and if the ping is not going out, so how do you find? Is it my ARP payload is stacking up in my packet? The whole thing is called as a Ethernet frame. And there are more inside the Ethernet also. You can see the destination max as all Fs if the destination is unknown. That's how the switch works, right? So let me give a little background about this, and then we will jump into the lab. And one more information I want to give you. I have given the links in the chat where Hemu has explained about how to set up the EVNG lab from the scratch. And also he has done a video how to set up the EVNG lab in Google Cloud. So you have two options. One is running on your personal computer and the other one is on GCP. And as I said, on your personal computer, 16 GB is sufficient. 32 GB would be great if you have, if only in where I mean, in a particular scenario where you might be using 32 GB is when you have your Palo Alto for VPNs, we might be using maybe about around 16 to 18 GB maximum. That is one scenario I have seen. You may have to use it. If still, if you don't have a 32 GB RAM, I would suggest to practice with Cisco routers because the VOEOS routers it consumes 1 GB maximum. So you can play around with that if needed, or else in your production network, just take a capture, don't do any changes, take a TCP dump, and you can see the packets and you can compare what we are doing in the lab. Or else also I have given an option. There is a rental lab, so you can reach out to the guy who can help you for it. And that's pretty cheap if you ask me. For a month, if you take a rent, then you can practice the whole thing. That is the other option you have. You have three options. Also, you can try in your GCP, Google Cloud, and you can try that. So these are all the options you have for it. And also, I will share the documents and the files which is needed to build a lab in your computer by end of today. And along with that, I will share the uh, PowerPoint presentation with you by end of today. So that's something I want to tell you. Then going back to this Ethernet frame. Let's compare this. So as I said, the most important thing you would be seeing is your destination MAC. Then comes your source MAC. Then your ether type. These three fields are most important. So ether type is going to tell me, is it what is my next protocol? Is it an ARP? We know this source MAC and the destination MAC. Sorry, and one more header is your VLAN header. So it is going to tell you what is your VLAN ID. So imagine this is a switch and you have multiple ports like this, and you have your PC connected. So this is all in a single broadcast domain. So let's say it's a flat single broadcast domain, so VLAN one, default VLAN. So PC here, it doesn't know anything. I mean, it won't interpret any values related to your layer 2. We know that. So it just works on your layer 3. So what happens here? Imagine they both are in the same subnet. So this is 10.0.0.2 and this is 10.0.0.1. So when the PC tries to reach 10.0.0.2, how the switch is going to handle is accept the incoming port here, accept this incoming port. It's going to broadcast out of all the ports. So it has something like a CAM table. For example, this PC has a MAC address of BB and this is CC. And there are other PCs. Still, the communication is happening between this PC1 and PC2. Still inside your CAM table. So it floods the information out, except the incoming port. It floods the traffic out of all the other ports and it learns the MAC addresses of all the ports. And it's going to update its CAM table with the MAC addresses. Example, PC1 is BB and this is on port 3, it is CC. So the the communication happens in the layer 2 between BB and CC. And if I ping, it's going to tell me, okay, inside my ether type, it's going to tell me it's an ARP. Yeah. So this is a simple packet flow happens there. So coming to your layer 3. So what is the other option I can see in my layer 3 header? So I will see the version number. I'll take a different pen for this. So it is going to tell me, is it IP version 4 or IP version 6? And this is a type of service, as we call this as a diff serve. As if you are using any kind of a QoS, it's going to show you, is it any kind of QoS treatment has been applied to it. And this is something very important when you troubleshoot a problem, when you send an ICMP pings. That's something you can see. It's an IP identification number. That's an IP ID. For example, if I send four ICMP messages, an example I'm telling. So it starts with an IP ID 0x001. The second ICMP packets is going to tell me 0x002, 0x003. This is all generated by the operating system. So we have no control with that. But for the troubleshooting, what you can do is, okay, I am sending four ICMP echo messages. Sorry for that. Echo messages, and I'm going to get all this reply back. For all the four ICMP echo messages, I should get an ICMP echo reply. So if I miss anything in the middle, because of this number, I'm going to figure out, is it something I'm missing a packet there? And if there is a NAT device in the middle, if you are doing an ICMP example, you got three devices like this. This is router 1, and this is router 2, and this is router 3. This is all connected. And if your communication happens like this, 12001, and it is a different network out there, 13001. So if your ICMP communication is happening between these two, if you send four ICMP packets, I should receive the four ICMP reply back. So using the IP ID, you can figure out, okay, why for my ICMP message with the IP ID 003, why I didn't get an echo reply back. And coming to this, the other important thing you will be seeing is the fragment offset. This comes when we do a fragmentation. So let's see in the lab now. All this, whatever we have discussed, we will see the package first. So in the beginning, I would suggest don't overthink about all this. When we keep learning about this in every classes, you'll start remembering everything. And if you do a practical, you'll remember everything. And also when we do practical troubleshooting, you'll understand this better. So now let me show you this. Uh, so how to set up a lab. So, and also one more thing, ensure that when you are installing your EVNG, when you do a capture, that's a very important thing for this particular course, especially. Once again, let me close the other labs. I think there is something turned on. Some 15 nodes. Um, Let me log out and log in back. I think looks like a bug. I'm going to add a router and a small switch. Then one more router. Why it's telling me didn't turn on anything else. I'm using a different RDP here. So let's turn on one more switch. So very simple topology where we got a router, two routers, and one switch in the middle. So the plan is here we are going to create two different subnets. This side and this side. So we're going to use only this R2, a connection between R1 and R2, and then from R1, there is a connection back here. So here I'm going to use the same 10 network here. So here we will add one additional network. Let's do a naming convention again. Yeah, well, let's do from the scratch. So let me change the host name to R1. Show IP interface brief. Exclude unassigned. So on Ethernet 0/0, here I am using 10.2.2.1. and Ethernet 0/1, 10.112 here. And going to the R2 here, it's 10.111. It's a point-to-point link between R1 and R2. So here we are going to configure one more thing. So this interface Ethernet 0/0 goes to R3 and it is 10.2.2 subnet. And I'm going to configure one more here, Ethernet 0/2. So for that, let's give 10.3.3.1. Okay. So these two point-to-point link, one is 10.111 here, and it says 10.112, and this is 10.3.3.1. This is the gateway on this, and this is one more interface. It is configured as 10.2.2.2 network. I'm going to configure the gateway here because I have already configured 10.2.2.2 that goes to R3. 10.111 subnet goes to R2. Interface Ethernet 0/2. IP address 10.3.3.1. And the subnet is /24, 255, all 255, 0. Move shutdown. So the interface status is up. There's one flat VLAN here. We're going to configure on switch 2. It's a flat VLAN. We are not going to configure anything. So IP interface brief. Sorry for that. I mean, we have to see the tag packet, so I have to create a VLAN. So let me create a VLAN, VLAN 10, layer 2 VLAN. So it can be, it works as just as a layer 2 switch. So I'm going to make this Ethernet 0/2 as a trunk because it goes to the R1. So this is pretty old code, so I have to enable the encapsulation, switch mode, trunk, encapsulation, .1q, switch port mode, trunk. So here on the switch, the other end is connected to a PC where I want to simulate some traffic here. So it is Ethernet 0/1. Interface Ethernet 0/1. I'm going to make this switch bounded to VLAN 10. I'm going to assign an IP address on the same subnet. So let's give this as 10.332 slash 24. So I'm going to the switch. Sorry, I'm going to the PC. If you give IP and question mark for this, this is a VPC that comes default with event G. Right click, add a node. So you will have an option. By default, you can use this VPC. And if you don't know the commands to use it, it's very simple. So you can give IP space question mark. So it will give you a format how to configure your IP address. So this is a format where you can use to configure an IP address. So this says that, okay, this is my IP address of this PC and slash 26 is the subnet mask and this is the gateway. That's how you can configure. The easiest way of doing it. So here we are going to change an IP address. So our IP address is 10.3.3.2 slash 24. Here it is 10.3.3.1 is the gateway. Show IP command will show you the IP address. So this has been assigned with 10.3.3.2 and the gateway is 10.3.3.1 and this is the MAC address and this is a layer 2 MTU for this port. So we'll talk about the layer 2 and layer 3 MTU in some time. So let me jump back to the R1. So the port is up, but I have to enable I have to map the tag to it because it cannot understand if I just assign an IP address like this because it's coming with a VLAN tag. So I want to delete this interface. Sorry, I have to remove an IP address from this interface. No IP address. Create a sub interface so that I can do a tagging on the switch on the router. Paste .10 for easy identification. Encapsulation .1q. The VLAN number is 10. Then IP address 10.3.3.1 255 255 255.0. No shutdown. You show IP interface brief. Exclude unassigned. So let me try to do a simple ping across. Ping 10.3.3.1. Host not reachable. So let me do a right click. Capture Ethernet 0 on the PC. This both happening at the same time. Should not happen like this. Let me try here. something changed. Okay. One second. Can't even start here. I don't know why it's driving me crazy here. Second. I hope everybody can see my screen, right? Can you guys see my screen?
Yes,
Yes,
Prabhu.
Okay. So let's modify this topology a bit. So here we will have a 10 network on the left hand side. 10, 1, 1, 1. Let's make it simple. 10, 0, 0, 0 slash 24. So on VLAN 10, so let's make this as a router as a stick. You guys might know about this, right? So we make this L3 interface here. This switch acts just as an L2. So it's a router on a stick. So we are going to create a sub interface on this router for different VLAN communication. I'm going to duplicate this, add one more network. Let's say this is 20. Say this is VLAN 20. So that we can see the tag packets. On the other side, let's make this as 30. Just one network here for testing. 30 here. So here I'm going to assign 10.0.0.2 for this guy. 20.0.0.2. Let me make this as a host name is R1. Let it go change the name here, R1, save. Let me create two sub interfaces. So the actual physical interface is GI0/0, no IP address, interface GI0/0 dot 10 sub interface, encapsulation dot 1Q 10, IP address 10.0.0.1/24 255.0, no shut. Going to the I'm going to create one more interface for VLAN 20 0/0.20, IP address 20.0.0.1/24. Okay, I have to enable encapsulation dot 1Q first. 20, the address, no shutdown. Save the config. Open this, switch, config. We have to create two VLANs because we are using VLAN 10 and 20. I'm going to create two VLANs, layer 2 VLANs, VLAN 10, VLAN 20, just a layer 2. And I'm going to assign the ports. So if you look at this, this is GI0/3 on the switch, GI0/3, IP address, sorry, switch port access, VLAN 10. And always especially when you connect the VPC device, you have to bounce a port once. So most of the time I have seen it didn't work when you connect directly. You have to bounce the ports. That's the best practice you can always do when you connect to this VPC device connected to the switch in even G or PNet. This is GI0/2 that goes to switch port access VLAN 20. So a small change here, has to be VLAN 20. So this port is for VLAN 20. Shut, oh shut. And the other thing important is the GI0/0, it goes to the router. It has to be a trunk to carry the tag traffic to this router. GI0/0 switch port trunk encapsulation dot 1Q switch port mode trunk interface GI0/0. I think it should be, let's see, show interface trunk. Trunk is on GI0/0. So I'm going to interface GI0/1. Let's make it as a trunk switch port mode trunk encap switch port trunk. First I have to enable the encapsulation. This is older switch. Newer switch doesn't need that encapsulation dot 1Q. I can just do a trunk, it automatically encapsulates dot 1Q there. But here, since it is old switch, you have to do an encapsulation dot 1Q followed by trunk command switch port mode trunk. So I made this as a trunk link here. This is 30 network. So going to this router. Configure host name R2. Configure, let's do, okay, GI 0/0, IP address 30.0.0.1, 255, 255, 255.0, no shut. So the link is up. So let's see the packet flow now. So I'm going to ping from here to VLAN 10. I'm just trying to test the basic connection, IP communication between this PC and the router interface gateway. So for that, I have to assign an IP address. So I have to give IP question mark. It will give you a format to assign an IP address. So I'm going to pick this format. So here it is 10.0.0.1. So I'm going to give an IP address in a same subnet 10.0.0.2/24. This 10.0.0.1. If I try to ping, it says host unreachable. So let me take a capture Ethernet 0 from the PC standpoint. Okay, so I'm going to run a continuous ping here. -T. Send packets until uninterrupted by Control C. Okay, let me stop this capture. Open this. So the request is coming from 10 network. So this is called as a display filter where I'm going to check. So I'm going to reach for a destination 10.0.0.1. So I'm going to give IP.address equals 10.0.0.1. I don't see any packets. So in the display filter, you have three different options where you can choose your IP display filter. So when you look for a specific IP address, you can give IP.source equal 10.0.0.1. That shows that all your source IP address which starts with 10.0.0.1, it's going to display. So mostly if you look for a specific subnet, it has to be /24. This is for the source. So for the destination, IP.dst destination equal 10.0.0.1/24. Sorry, 0/24. So in generic, if you don't know this particular IP address as a source or destination, you can go with a generic display filter, IP.address equal 10.0.0.0/24 for the whole subnet. If you want to look for specific IP.address equal 10.0.0.1 ADDR address. It automatically populates here when you don't know this commands address equal 10.0.0.1 generic. I mean, always try to give a generic until you get familiar with that. Then if you want to look for source and destination, you can go with that filter. So if I am trying to find the subnet for 10.0.0/24. Why I can't see anything here? Because the IP communication is not happening in this case. So what I should check here, I have to check for my ARP protocol, right? Because there is a layer by layer. If you remember what we discussed in your layer 2, if I open this header, you can see that if I click on this, you can see the source as this particular IP address. We'll see there, and this is a destination, is a broadcast. So it doesn't know where I have to send this, so it is broadcasting out. And one more thing, as I said, this is called an type, is called an ether type. So it says my next protocol is ARP. So still there is no ICMP communication is happening, right? So this is called as ether type. If you remember in the header, we discussed this. So we see this destination MAC, source MAC. So it is broadcasting, and this is an ARP request, and we get an ARP reply back. ARP request is a broadcast. If you open the ARP header, you can see what are the key informations you can see. You have three informations, known three parameters. One is I know source MAC, I know the source IP address, I know the destination IP address, but I don't know the destination MAC address. Until I get to know about the destination MAC address, this packet cannot be forwarded. So until this point, so it is telling that who has 10.0.0.1, tell 10.0.0.2. So this is a packet that's exactly we captured from this 10.0.0.2. We assigned this. So it is asking, do you know how to reach there? But who has to respond for this ARP? Who is this is an ARP request going out. So here my ARP request is going out. So who should be the ARP responder? This guy has to respond for my ARP. So he should be sending an ARP reply back. But since this switch, when the packet comes here, so this is purely a layer 2, right? So what happens here? So I know the source MAC now. It learned this because ARP is a broadcast, so it sends out the packet out of all the ports. But switch is a layer 2 device. So now it got the detail of the source MAC, but it doesn't know the destination MAC. We got the source MAC. Right, let me erase this. So we got the source MAC, but we don't know the destination MAC. So the switch cannot forward this packet back to this, and I am not getting an ARP reply back, right? So now from this, what I can figure out, okay, I don't know the destination MAC address. So for the very first thing, what you have to check, let me go to the switch. If I do show MAC address table, so I know GI0/1 MAC address, but I don't know the MAC address of GI0/0, what I learned on GI0/0, and what I learned on GI0/3, as well as GI0/2. So for this, I mean, it is just a ping. So I saw the packet. So the switch doesn't know the MAC address, so it is not forwarding it. So in the Wireshark, it shows I send an ARP request, right? The PC sends an ARP request, but for the ARP request, I didn't get a reply back. So what are the key details you have to see here? Okay, this is a source, and it is doing the broadcast, right? The PC is doing a broadcast, but even though after the broadcast, switch is not learning the MAC address here. So what could be the problem? So I have to go and check the interface level, right? Show interface Ethernet 0 slash. GI0/3. So it says the port is up. Both my line protocol and link both are up. Show interface status. It says it's connected and GA0/3 it's connected, and you can see this is on VLAN 10. But still I couldn't connect. I said there is some problem with this event G. I have seen so many times. You have to bounce support. Before that, you have to confirm your configuration. Go to the interface again. Interface GI0/3. Shut. No shut. So now again, I'm going to the VPC here. Let's change this name as VPC1. There is an option to change. Save the config file name ping. That's an option too. Okay, so to differentiate this connection, let me just change the color of this. So this is VPC1. So let me give show IP. So I should see this 6886 MAC address on the switch. Only then it can forward the packet back. So again, I'm going to ping 10001. It says host unreachable. Show MAC address table. So now I can see the MAC address after the ping. So it learned on port GI0/3. So I'm going to check my trunk interface now. Show interface GI0/0. Still up. Show run interface GI0/0. .1Q, and it says it's a trunk. So let me go to the router R1. Show IP interface brief. Exclude unassigned. So if you look at this is admin down. If I go to the interface, shut, no shut. Again, give show IP interface brief. Oh, shut. Oh, I think I didn't do the shutdown on the physical interface, right? GI0/0. Oh, shut. Yep. I give show IP interface brief. So now let me try to ping this. And also in the meantime, let me take a capture. Let me close this capture. Take the capture again, right click, capture. Ethernet 0. So I can ping now. So let me go and stop this. There's an option to change this layout. You have to put this payload back there. Fine. So if I going to give the same command, IP.address equal slash 24. I'm looking for the whole subnet. So I can see both my source and destination here. What if I'm troubleshooting a problem, something related to my source? IP.address source 10.0.0.2, right? Because the traffic coming from 10.0.0.2 going to 10.0.0.1. Most cases we'll see that. Or else with the destination. Either way you can do it. So when you click on this very first packet, this is all ICMP packets, right? So before that, how this packet encapsulation exactly happens, as I said, first you should see your ARP. So now, earlier my ARP was failing. So now if I give ARP, so I got an ARP reply back right over here. And also there's something called a gratuitous ARP. We'll talk about that. But first, for my ARP request, and I should get an ARP response back. Let me make this a little bigger. So let me go into the layer 2 header. What I can see. So now I see this is the destination IP. This is, yeah, first is a destination MAC address, then source MAC address. Then it says it is a ARP packet here. And you can actually see the payloads right over here. If I click on anything, example, this is a destination MAC. You can see this, the payload right on here. On the payload, you can see this header. On the header, you can see the destination MAC address. So this is the whole payload what you're looking in the bottom. So on the Ethernet header, now I can see source and destination. This is on the final packet what I got. In the ARP request, if you see, this is an ARP request where target is a MAC. It's a MAC. What is that? It is flooding this traffic, right? All left. It is layer 2 flooding. In the layer 2, if you see this, this is layer 2, and this is a broadcast. In the Ethernet header, additionally, you should see this. If somebody is doing a broadcast or multicast, it should show the value as 1. If it is a unicast, you should see the value as 1 here for the unicast. But now it is a broadcast address because it's a layer 2 broadcast, and I am on the layer 2 header. So all of the four information key informations you should look into your layer 2 for when you're troubleshooting. You should know your destination MAC, you should know your source MAC, you should know your ether type. So ether type is ARP. So the next protocol is ARP. For this ARP request, I should get a ARP reply back. Only then the communication goes up to layer 3. If you look at this, the next protocol, it says it's an IP, and if it is a successful connection, only then I'll get an ARP reply back for it. And if I click on this, layer 2, so this is an ARP reply. So for my ARP request, I got an ARP reply. But who has sent this ARP reply back? So this is 10.0.0.1. He should be the responder, right, for this ARP request, because he owns that MAC address. So these are the key values you should know before you're forwarding your packet. So in your ARP reply, if you see, so sender MAC address is same, the PC. The sender IP address is 10.0.0.2. It's a PC again, but the target MAC address is whose MAC address is this 8500? If you go and check in the switch, so GI0/0 8500 is the router's interface MAC address here. So I should know that. Only then the switch, if switch learns this MAC address, only then it can forward the packet back to R1. This is just one ICMP. But this is a bit in the whiteboard. Let's go with the basic small topologies, then we can go for a bigger topology. That's my suggestion always. Because when you start with little, then you will understand better. So you got your switch. So the general purpose of we are segmenting the network into VLANs is, okay, we got VLAN 10 in our scenario. This is VLAN 20. So you got your PC. This is a switch. So we connected two PCs. We are talking about two PCs. So let's come from the layer 2 and layer 3. What are the key elements I should see here to forward the traffic? From the switch perspective, I should know the MAC address. All I should know is a MAC address, because that is a layer 2 device. We know this. But how this exact encapsulation happens, because we are talking about until the layer 3 forwarding now. So how did we troubleshoot? Even if you have a troubleshooting, if you have to apply the same logic for a bigger network. So now you're talking about a one single subnet where I have a problem with my IP communication. So now here we assigned an IP address. The port was up, but the packet was not forwarded. Why? Because for my ARP, first packet that goes out of this PC is an ARP when you do a ping. So when you do a ping, well, for the very first time, what it happens when you do a ping, your packet leaves this PC, right? This is PC1. Your packet leaves your PC for the destination 10.0.0.1. And what is my source? 10.0.0.2 is my source IP. And I'm trying to reach destination IP address. So what are the key details when I'm doing a troubleshooting I should know? So first, if I take a capture, in the first capture, if you guys remember, there is no destination MAC address. But very first time when you do an ARP request, what it happens, if it is in the same subnet, it doesn't go to the gateway for sure, right? Because it sends a ARP request, and what it has sender MAC, sender IP, destination IP, but it doesn't know the destination MAC. So I need these four information for my successful IP communication. So first, so for my layer 2 broadcast, first thing the switch should know about the MAC address. Only then it can supply the MAC address back to the PC. Only then it can forward the packet. So when it hits this, the PC hits the switch, all it's going to look is, okay, do I know the MAC address to send this packet back to the proper destination? So here in this case, since I didn't enable the interface, even though I try to, and shut the sub interfaces, the physical interface is not up. Obviously, if the physical interface is not up, it's not going to supply its MAC address back to the switch. So for my ARP request from the Wireshark, instead of going to the router's configuration in every scenario, say for example, you might have a situation where you can't log in the switch, or they might be giving a capture. From this, you will get to know, okay, I don't know the center MAC address, so I feel that So does the switch is actually learning the MAC address? Because without the MAC address, it can't forward the packet. Because in my ARP request, there is no ARP reply back because it is doing a layer 2 forwarding. But for the layer 2 forwarding broadcast, I should get a response back. So for this ARP request, since once we turn on the interface, the switch learned the MAC address. And for this ARP request, who is the ARP responder here? So it's a router connected to the switch here, and we configured the default gateway 10001, and I want the MAC address of 10001, the MAC address which is configured on this, so not configured, I mean it's a MAC address on the interface. It has to supply the MAC address back to the switch once the switch learns this MAC address. So I got the MAC address. So now who is the ARP responder? So the 10001 is the ARP responder. Just thinks it is a host in a device where I send an ARP request. I have to get an ARP reply back for my successful communication. So now my layer 2 is satisfied. I got the source MAC, I got my destination MAC, right? So then comes your layer 3, and in your layer 2 we have seen that we have to see something called as a ether header that says it's an ARP request. In the layer 3 you're sending an ICMP. So for my echo, I should see the echo reply back. But for all this communication, what I need source IP, source MAC, destination IP, and destination MAC. So, but I have all these three details by default, but I don't know the destination MAC address. But if there is a proper MAC address, if I learn, only then the packet will be forwarded. So let's see how the switch looks into this, right? This is all from the PC standpoint. This is a layer 3 device. So let me go back to the switch and see how it is tagging the packet and how it looks a packet in the layer 2 header, additional header, what I can see there. So now let me take a capture on the switch, go to right click, capture, and the interface is GI0/3. Right click, capture GI0/3. Close this capture, have one capture at a time. So the capture is running. Again, I'm going to do a ping, a basic ping. Going to the capture. Same thing, IP dot address. I'm going to give 10001. So now, if I open this capture, this is the capture we have taken from the switch. So if you go to the ARP, if you see the ARP, what is the protocol I can see in the ARP packet when before this IP forwarding in the ARP, I can see the ether type as ARP. This is the ether type number for ARP. But if I go to this ICMP packet, so what it says now it is a IP protocol. So step by step. So when I do a ping very first time, the ether in the layer 2 header, it's going to tell me that the ether type is ARP. So once I get a successful ARP response back, then it changes back to IPv4. If you capture your ICMP packet. because I got a ARP response back. Now, what is the next protocol it has to reach when you look at from the OSI layer? It is IP layer. So without knowing the ARP response back, without knowing the destination MAC address, I can't go for the higher layer. So there is a successful communication. By looking at this, you come to know, okay, my destination MAC, I learned the destination MAC. There is no problem with the switching. Switching is clean. So I don't see anything wrong with that. So this is a ICMP request, right? If you see the header, how it is changing, the source is the PC, the station, and 8500 is the interface MAC address of the router. So if you see that this is a request. So what is the reply back? So reply, who is sending a reply? So this is 8500 is a router. It replies back to the computer, the station. And this is something I am talking about, the IP identification in the layer 3 header, right? So if I right click this, apply as a column on the layer 3, right? I have to go to the internet protocol. So let me collapse this. Let me expand this. IP identification, right click, apply as a column. See, this is an IP identification. So you can see now 6299. So this is a Wireshark way of representation here, right? So it says 6299. So my first ICMP request goes out of the computer 10002 is 6299. So I got an ICMP reply back 6299. The second packet, it's an increment of 1, 6300. Second packet, I got a reply back for 6300, 6301, 6302. So the number of ICMP packets, whatever I am sending. So from this, I can calculate, okay, my bidirectional communication is happening properly. I don't see even a single drop an ICMP reply back. Say, for example, if there is a congestion, if something is happening, when you follow across this, you may miss something multiple times. I'm telling you, at times the router is the what does it say? It is very intensely working and it is slow and it is not responding for your IP packets. Then you may not see this identification numbers coming back for your requests. So you can come to know, okay, there is a latency. I'm dropping the packets. By just if you remove this, you can remove this column. By looking at this, still people will calculate with request and reply. Imagine you have 100 packets you have sent. But with the identification number, it's very easy for you to track every packet. In a sequence in which particular packet it is failing and how many packets I have sent, how many packets are failed. So you can have a crisp understanding of what fails and in which particular packet I'm losing a packet, why it is not sending back. So using the identification number, you can also figure out, okay, so apply as a column. So I send a request, but I didn't get a reply. Or maybe it sent a reply, but it didn't get the request is not it sent, so I didn't get a reply back. So it will help you to troubleshoot better when you have this. So now let's do a scenario where we will do a continuous ping and we'll bounce the interface. What happens? Let's see. So if I ping 10001 and let me make this -t, it will run a continuous ping. So I'm going to the router 1 and also simultaneously I have to take a capture. So let me, okay, the capture is still running there here. So let me try enable show IP interface brief, configure interface GI0/0. Let me do a shut. Let me do a no shut. Let's go to the capture. Now let's do an ICMP. Enter. Six two double nine double six double zero 933 request reply. I want to see something failing here. So we are doing a continuous ping here. Okay, let's stop this capture now. Let's scroll through this. I'm trying to figure out for any of my ICMP request, is it something my request has been dropped? Let me go to the, okay, there are few request timed outs here. For that, the same thing, I should see the ICMP failing. So let me go to expert info, expand this, open this, right click, apply as a filter, select it, close. So I have sent multiple ICMP requests, but for all these requests, I didn't get a reply back. Starts from 6704, 5, 6, 7, 8, 9, 10, 11. So for my 7 echo request, I didn't get a reply back. So how do I find that? First, I have to do an ICMP, right? Because this packet is completely flooded. So I don't know how exactly I can filter it when there is a problem. So I'm going to ICMP. I'm clicking on the export info. So I filtered only the ICMP. So it shows the warning. So no response scenes for all this ICMP requests. So I'm going to right click on one and apply as a filter selected. Click close. It's going to show me all the ICMP requests which are failed. It says I don't see a response here. No response seems to my ICMP request. And one more thing, that's something we have to check the .1 queue traffic. I have to see the what VLAN it is coming from, because when you are troubleshooting a problem on the switch, you should see the traffic should be coming on the same correct VLAN where the port is configured, or if it is a port channel, right? That's something we have to check. So now let's go back to the switch. Close this connection. Go back to the switch. Let me do on the trunk here. Let's try on the trunk. I tried on the access GI0/3. Let me go to the trunk and let's try. Capture GI0/0. So now again, I'm going to ping the destination. I can see the packets. Stop this capture. So it says that my source is 8500. Who's that? 8500. This is the PC. Sorry, this is a router's interface. So I'm going to this. So I'm interested on this. The traffic going out, right? So if I click on this, this is my source, and it says that my VLAN is VLAN 10. So you can see that in your layer 2 header. What is the type? It is .1q VLAN, and you can see the ID number here. VLAN ID 10, and it is configured with .1q. I think we should see the same thing on the access. Let's try on the access. Do we see that? Is it still going on? Okay. So I'm going to GI0/3 on the switch, right click, capture GI0/3. So packet is full, it's completely done. Let me right click, capture GI0/3. Let me start the capture from the beginning, yeah, from the same interface. So I see the ping requests coming in. It says it's Ethernet frame. I have opened this. It's showing us okay. We go to this. Stop the capture. Okay. Fine. So on the access port, we are telling it is just a VLAN, but we are not configuring the encapsulation type. So it has, if it should reflect the encapsulation type, you should see the encapsulation enable. So apparently, I think you have to do it on your trunk port to see your VLAN tagging traffic. I couldn't see anything related to .1 queue on layer 2 here. So the key takeaway here is, so once my IP communication is not happening right away, so you can decide it can be a routing issue or switching issue. In your ARP request, right, in your ARP request, you shouldn't see the destination MAC address, as well as your next protocol should be on your layer 2 header, your next protocol should be ARP. Ether type is ARP. So ether type is something you should focus on when you're troubleshooting. And if your communication, everything is happening properly. And if you go to your layer 2, then you should see your ether type as IP here. Ether type changes to IP. But if you have a successful ARP communication, only then you can see your ether type changes to IP. We are using IPv4. If you are using IPv6, it should reflect as IPv4. So these are all the key headers you should look into when you're troubleshooting your problem. So now I'll give an unmute permission for everyone so you guys can ask your questions now. Hi guys, I gave an unmute permission. This is a Q&A so you can ask your questions.
Praveen, so in the access port, when we did the capture for the ARP reply, so the source MAC and destination MAC, what was showing like in the capture, just to understand the what.
Yeah, I mean, so source MAC is same, but destination MAC is something we don't know the destination MAC. That's the whole point of doing ARP. So it sends an ARP request out, and for that ARP request, we got an ARP response back. The destination MAC is a router's interface MAC address.
So that is once it's successful, like once the ping is successful, just want to see that how it was showing. Like, so we got the in the capture, it will show the destination MAC.
Yeah, in the ARP response, yeah, you should see the destination MAC, yeah.
Okay.
Yeah, that's the whole point. If you send an ARP request, in the ARP response, you should see the destination MAC. Only then the packet will be forwarded to the destination.
Okay. Can you show that capture like or in that Wireshark now, like just to see that part, like
Yeah.
you're getting it.
I think I didn't save the capture. We have to bounce support and let's try. So now I am on R1 here, this device.
Okay.
So I'm going to shut down the port. Configure interface GI0/0. I'm going to shut. Before that, I have to do a capture again. We are doing a capture on what? I think we are doing it on the switch. That's fine. Let's try. On the switch port GI0/0, or I think on the access port we are doing it. That's fine. Do shut, no shut. So if I stop this, you can do that, or else you can just type ARP. So there's a ARP request, right? It's with a question. So it is asking 10.0.0 to the computer, where is 10.0.0.1? So the computer can't respond back because it is a layer 3 device. So you can see the ARP ether type is ARP. This is an ARP request. Inside your ARP request,
Okay, I'm just trying to understand that. Who has 10.0.0.2? 10.0.0.2 is a PC, right?
yeah, PC.
So the ARP request is coming from the router now or
No, no, no,
switch?
from the PC.
Okay, because PC is having already the two IP, right? PC need to understand who
No, no,
has.
no. The meaning is who has 10.0.0.2 is what is the MAC address it is telling. It is asking for the MAC address. See, the
Okay,
Wireshark representation is different.
okay,
So the ARP request is leaving the PC, but it doesn't know the destination MAC address. It should have the four details to forward the traffic. So all it look for is layer 3 devices. It is bothered about only the layer 3. It doesn't work on layer 2. So now it is switch responsibility to get this MAC address from the destination and give it and update its MAC table. So once we got that for this ARP request protocol, we should get an ARP reply back. We should fill up all this detail. Only then the packet will be forwarded to the next layer. We are
yep,
talking about the OSI communication. So if this packet has to, this PDU has to move up to layer 3, I need this information. Only then your Ethernet, because your Ethernet frame now it is not completely filled, right? So you don't know the destination MAC address to forward the packet back to the upper layer. So it got stuck here. So we sent an ARP request. For this ARP request, we got an ARP reply back. That's something the PC responded back to us. So now the switch got the MAC address, and now it's a frame has been encapsulated and it forwarded to the upper layer for my IP communication. So without this ARP response, I won't get the MAC address and it cannot be pushed to the upper layer for IP communication. That's the whole point.
okay. So when the ARP request is sent, switch wants to understand what is the MAC ID of the PC itself, and it
The
and takes that
destination, the destination.
that is router's MAC ID.
Yeah, imagine I
Because
can say very simple example.
trying to because
Yeah,
I'm trying to
I
see
got
with
it.
the understand with the output, because here the output is it says 10.0.0.2 is at 68.86, right? So it means 68.86 is the PC or so PC is giving that um, no, this is my Mac.
No, 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 no. See, this is now the ARP request. Okay, this ARP request you're talking about. Okay, I didn't see this. So it is, you can see that, right? So in the ARP request, if you have always, if not a confusion, if you want to follow the packet flow properly, the sender IP is now, this is the router's ARP address, ARP request, sorry. This is a router's ARP request. I didn't see this actually, the output here. This is router's ARP request. For that, now the PC is sending back the ARP response back.
Okay, okay,
Because it
okay.
is in
Bec-
different network, so it will reach to the gateway first.
but this is the same subnet. Here, the whole point is we should get the destination MAC address. So now we try to ping from here, but for the ARP request is initiated from the router because we bounced the port. The ARP is flushed in the router, so it should know the destination MAC address, right? You should have the ARP resolution in your ARP table. only then your packet will be forwarded. Correct? This is
Now,
in the same subnet, so that it is not going to the gateway.
okay. Now, like the request is coming from the router and
Router to the computer.
computer PC giving to the switch, and then it is complete. But actually, it should be like when we send a ARP request from the PC, we should see some communication coming from the router back.
What is the question? One minute. See, this is my ARP table, right? So it will update the ARP table.
Okay.
So this is the protocol running on both devices. This is layer 3. But the forwarding happens from the switch perspective is if I know the destination MAC address, I can forward the frame to the upper layer for IP communication. As I said, in the ether type, you see if it is an ARP in the layer 2. So it means that my ARP resolution didn't happen. So once it got an ARP response back, the ether type changes to IP. So it means that, okay, I know how to reach the IP now. This is all happening within the protocol and the layer. We are talking about only the ARP now. So once we got this resolution properly happened, then it's encapsulated and pushed back to the layer 3. Then your IP communication happens. So why now in this particular situation, why the router send an ARP? Because once you bounce the port, what happens here? If you bounce this port, your ARP flushes, right, from that particular VLAN or whatever the subnets it has learned, the MAC address. If you do this, shut, no shut. Now I think we are doing a continuous ping on it, yeah? So stop this. If I give show IP ARP, shut. Okay. So I don't have any ARP entry now. The switch cannot supply its MAC address to the switch because my ARP table is empty. So in this case, the router will send an ARP request for it. Because either way it works, right? So from the PC to router, from router to PC, it's a bidirectional. Both should know its MAC address. Only then your ARP resolution, ARP request and ARP response should happen successfully. Only then your IP communication happens. Your ARP is the base communication before your IP communication. So in this case, I don't have an ARP entry for the destination 10002. So the router will do a ARP request for it. Even though if you do a ping from here, because it's a bidirectional, right? Ping and ping response.
Yeah, it's clear.
Yeah.
So I have few questions like so we the IP ID generate IP ID which we are showing in the packet diagram you are saying, right? Packet. So that will get like if we give 100 ping, so 100 IP ID will get generated. Right?
Yeah.
Just
Correct. For 100 ICMP requests, you will get 100 IP IDs. Yes. It's an increment. It is based on the operating system. I tried in Cisco, but I don't know about other Juniper or other device. The IP ID is a control of the operating system, how they designed. So it does.
And so in the captures, Wireshark captures, can we so like see some colors to differentiate the traffic? Like for example, like we did ping and reply was there. So if ping reply we did not receive it, will there be any color so we can?
Yeah. There is filters. Yes. There is a filters. Yeah.
Okay. Okay.
I'll show you in the next class to do
Sure.
that.
And also, can we see a timestamp or something in the Wireshark? Like if, for example, we see the.
Yeah, we can see the timestamp. I mean, we haven't gone to that level. I mean,
okay.
Yeah, but actually here, if you actually do a timestamp, actually this is a very good question. Even I prefer doing that. But when it comes to TCP, I do that. But even for ICMP, if you do, it helps you to find the latency between the ping and ping response.
Okay. Actually, I'm new to very new to this.
No problem. See, you have to go to view,
Okay.
time format, time since previously displayed packet. So it means that time since the previously displayed packet. You got it right. So it's right immediate to your previous packet. So if I select this, if I do ICMP, so the format should be changed here.
Okay.
So if I go all the way up, so I just follow this. So ICMP request has been sent and it took 149 millisecond. See, can you see two arrows here, the
Yes.
left
Yes.
and right? So for every ICMP packet, I should see a bidirectional communication and you can compare your time. Say ICMP request reply. So after 1 minute, it is waiting, right? So it is waiting for the reply. Then the second ICMP goes out,
Okay.
7360. So it sent after 132 milliseconds. It has sent a reply back to this guy. Third packet, 237 milliseconds. So if it is exponentially going high, something like this, to I think we bounce the port, I think there is some latency. If there is a proper communication, but if you see latency something like 3 seconds, 4 seconds, then it is a problem. And also you can compare the same with your output. If you go to your PC, see for every ICMP packet, see here this is something we don't know. This is a echo response or echo reply, right? So oh my God, it's gone. So we have to enable again. See, it took about 1.360 milliseconds. Everything is in milliseconds. Say 460, 415, 47, 217. So you would have done this, right? When you do a troubleshooting, when you ping without Wireshark, you would see if the latency is increasing, it will shoot up, right? You got it? What I'm telling. Even you can compare your milliseconds here
Yes. Yes. Okay.
as well as in the Wireshark, but don't compare both with the same values. That is different. This is different. But here I am telling when you compare your latency, you have to go through this timeline,
Okay. Like, fine.
not that. Yeah, that is different. This is different.
Sure.
Yeah,
Thanks, bro.
no problem. Yeah.
Uh, Hi, Praveen.
Hi.
I joined with
Yeah.
late actually.
Hmm.
How do you get these labs performing these labs?
Sorry, how do we?
Regarding this lab setup,
Yeah, I have sent us links in the chat. Do you guys see that in the chat? I mean, oh, okay. I think it's gone. Maybe in the previous session. I'll give that now. I'll give it in the chat. There's
right?
two links I've given, I think. Did you guys copied? I think you guys have missed
Yes,
it.
yeah, I
No,
got
no,
it.
no problem. So this is the whole EVNG installation from the scratch. How to do that, and also I will send the files. You follow this video and install using that file.
Regarding that switches and routers images,
Yeah, correct. Switches, routers, firewalls.
okay.
Hi, Praveen. So today only I joined. One question regarding the ARP. Like if there are, let's suppose, I mean, like there is a huge network, okay, layer 2 network, and we can see like thousands of app requests, and like few are failing, or I can say, let's suppose like 30% of the so there is a issue like that users are getting drops or users are not able to communicate. Okay. So how we can identify like out of those maybe like million of packet, how we can filter out? Is there any way?
Yeah, very simple. You can do 1 second, I'll show you how to do that. I think this is EVNG full setup. Okay. I'll send you one more for GCP now after this question. Your question is okay. So for example, what is that? Can you rephrase one more time? There are
Yeah.
millions of.
So now we can see, I mean, like, see, actually, like, if we are taking the captures as well, like on the switch port or anywhere, lot
Mm-hmm.
of other devices will also be connected, right?
Yeah, yeah.
So either, see, like, not everywhere is possible to take the captures or to take,
Mm, mm,
we have to do like somewhere we have to do span or port
mm.
filtering,
Yeah,
right?
yeah, yeah.
So, like, let's suppose if I'm taking the captures, even with
Mm,
the conditional captures on the firewall
mm-hmm.
or like
Okay,
any layer 3 device where the captures are possible, and I can see like lot of traffic, million of
okay,
traffic.
okay.
Now, I want to identify whether like something related to ARP is having any issue or not, particularly for those end clients who are
Mm,
facing the issue.
okay.
Okay, so I mean, like one or two, I can check. I can create the filters like based on the source and destination. But is there any way who can tell us overall, like these many requests are coming and these are failing and these are
Yeah,
the spoof requests?
yeah, yeah, you can do that. I'll tell you. Let's do a capture again and I'll show you that. So, okay, let's do a continuous ping again. Okay, I will take a capture from this router. I'll show you that. So let me shut down this port. Is it still successful? Okay, request timed out. This is not the right capture, I think. I think the port is shut down, so it's not generating any traffic. So I'm capturing the traffic on the PC. That why I should. Okay, show.
ARP hyphen A, like is it a Linux only?
Yeah, I think so.
Mm,
Um,
just something else.
IP ARP. P ARP 10.0.0.1. I think show
IPR.
show
Sure.
ARP, I think. Yeah.
Yeah.
Show ARP. ARP is empty. So very first packet happens when there is a successful ping. Yeah. So we shut down this link. Let me bounce this port. Okay. Let me stop this capture now. Think. Okay. So this is the ARP request. This is ARP response, right? So
Mhm.
you're asking me if I have a problem where I don't see any ARP response back. How do I find, right?
No, let's suppose
Yeah.
1,000 users are there,
Got it.
400 users are having issue.
Got it. So if I give arp.code equal to 2, arp.code 2 is for reply,
Like,
right? And also you can add an additional filter. You have 1,000 users and they don't get from, they didn't get an reply from a specific subnet, right? An example.
yeah.
Let's say 0/24 and so from this you can figure out only the specific subnet where you don't get a reply back. And also if you want you can add this. Do I get that with the ARP code you can find
OP code,
this
okay,
is
reply.
yeah, reply. So if I do select and I can give a subnet and IP dot address equal 10.0.0.0/24. You know the subnet, right? So you should see for a request, I should see a opcode reply back for it.
Okay.
If I don't get it, then I don't get an ARP response back for that specific subnets.
And
So here,
second,
sorry, the filter here is always it should be green.
no,
Some
IP, I think
typo.
there is some space.
Yeah.
Yeah,
Yeah. Now it is correct. Yeah.
understood.
Like this, you have to keep.
And like if someone is spoofing the ARP, like if it is generating like way more packets, and if it is doing like with the distributed, that also like we will get, right?
Yeah, there is
Yeah.
a separate class for it. Yeah, there is a concept here where we'll discuss about DDoS attacks
Okay.
and
Absolutely.
R spoofing. There it comes when we discuss about what is that? There is some additional bonus I was talking about, right? When we do an in-map, in the in-map we will do that ARP spoofing.
Okay. What's the difference between like previous capture packet and delta time, frame delta time?
Okay, previous capture is you don't have that exact timeline defined there. With the delta capture, you will see the exact time. If you read this, you'll understand. It's a time since a previously displayed packet. The time format has been changed to second since previously displayed packet capture. Sorry, time since previously displayed packet. It means, okay, my packet has been sent with 0 seconds and I got a reply back after 70 milliseconds, an example. So if you select this particular option, it will show you exactly when it started and how much time it has taken to get a reply back from the destination.
Okay, and what is delta time then?
No, delta time is a predefined time in the. You mean, okay, the delta time you're talking about a different
Yeah.
delta time.
Okay.
Even this is something I'm talking about. The seconds we can adjust there. Delta time is for comparison. That's for TCP. I will teach you what is delta time.
It is in TCP.
It
No.
is a different way of. It is not the normal time. The delta time is. I would say this is both are similar. Okay, but both you can use either a specific delta time as an option, or else you can use a second since previously displayed packet. Both will give the same result. I will show you with the output. If I will select this, and also I will add one more column as a delta time, and you can see the both outputs. So the delta time is something, it calculates the time. See, the timer starts with 0. You send a packet and it will wait on how long it is waiting to get a response back from the destination. That is a delta time. The
Okay, so
meaning of delta
the
time is
reply, that the time between the request and reply.
reply. So if you are not selecting the delta time, what happens here? It randomly it takes, I think, the default time, whatever you have. I think now we selected this. If you see UTC or daytime, it just calculates the time based on this. You will not get a what do you say, accurate time. So to get an accurate time, you have to go with either second since previously displayed packet, because it calculates the time since the previously displayed packet. From there, from that time, it will starts calculating the time in your output. Or else you should have your delta time. So it does the job. Both does the same job.
But with UTC as well, like if I have to convert, I can add like +4.
I think this is a bit of confusion when you add this. I would always suggest you always have either second since previously displayed packet, or you should have your delta time as your reference to check.
So
Because
there is option to do the time shifting as well, correct?
I haven't tried that time shifting. I don't know
Uh,
how it impacts there, but the whole point is whenever you try to figure out a problem, we always look for the RTT, round trip time. So for RTT troubleshooting and packet analysis, it is always to go with second since previously displayed packet or delta time. I never used all these time frames apart from those two.
Understood.
Yeah.
Thank you.
Yeah, no problem. And what's your name?
Deep.
Deep. Okay. You're
Actually,
you're from you're based in India, but you moved out to a foreign country.
no, I'm based in India only. I'm
Oh, okay.
working, like I'm having 12 years of experience, and I have worked pretty good on Wireshark.
Okay.
But thing is, like somewhere, like in the SSL and such
Mm.
scenarios, I got struck a lot.
Mm, mm, mm,
The
mm.
decode
He,
and this.
yeah, here it's just a logic. See, if you go for ARP, you can also do this. Say ARP code and ARP generally ARP code 2. In this scenario, you are using ARP code 2 because you should get an ARP reply back. You should see all your ARP replies. So it is just how logically you can apply your filters. That's it.
Hmm.
But for that we should understand the layers, how it works and how this is encapsulated. That is
And
also important. Yeah.
yeah, yeah,
Okay. Thank you, Deep.
yeah.
Yeah.
Thanks, Praveen.
Any other questions, guys?
Praveen, about Gracious Harp, could see
About
some.
Gracious Arc, I mean, next class will continue with Gracious Arc. So we will finish everything. Don't worry. If we talk about ARP, we will finish all the ARP flavors.
So, Praveen, you
Proxy
mentioned
ARP and Gracious ARP is pending. Tell me.
uh, you mentioned the two is for ARP reply then, right? Is there any number for request, ARP request?
I think it's ARP code 1.
Oh, one, okay.
It is code 1 only.
It's ARP code 1.
Code one, okay.
Reply in this is request. ARP code 1.
Oh, code one, okay.
So you can see only the ARP request, no reply. Got it?
Yes, yeah, thanks.
Praveen,
Okay.
a recording is there, right, for the studies also now?
Yeah. I recorded. I mean, I started this recording after we had some disconnection in the middle.
No,
Then
not.
I recorded.
I'm asking about the yesterday one.
Yeah, yesterday is recorded. I think apparently you should see it in the evening.
Okay, thank you. And for
Yeah.
the lab, you given me the number. I will reach to that guy to take this access. Yeah. Today.
Yeah. You can reach out to him. Yeah.
Thanks. Yeah.
So, sorry, Praveen, another question. So this ARP traffic packet data, it will generate every time when any device need to know the next hop or what is the next hop, all that, right?
If your device doesn't have the ARP entry and in the ARP table,
Mhm.
your ARP request happens. If it knows
It
the
will
ARP
happen.
reply, you got an ARP reply and you have your ARP table updated, then the device is not going to do an ARP every time.
Yeah, you mean that if it's there is no MAC entry in the
Yeah, there is entry
cam
for
table you mentioned.
yeah, ARP table, not CAM table, ARP table.
ARP, okay, ARP.
Yeah.
Okay, thanks.
No problem. Yeah.
Yeah, are we going to cover the basics of this Wireshark tool itself, like that features and all? I mean,
Yeah.
okay.
I mean, how about you guys? I mean, you guys said you have everybody, most of them here, they have basic understanding of Wireshark. So do you guys need the options, filters, coloring rules, and everything? I come to know about that coloring rules and everything.
Yeah, so those,
Mm.
I mean, like, to be honest, I haven't worked on coloring statistics per se.
Sure. Next class we will cover that for sure. Yeah, that's very simple. Create your own display filters, columns, and everything. It's very easy.
Yeah, that if you can little bit explain that all the features like what we can use in the Wireshark, that will be great.
Yeah.
So
So there is a separate session. See, I have a proper what is it syllabus. Then I will unveil everything step by step.
Mhm.
Yeah, this is for sure. Yeah, I will walk you through the options, what we have, coloring rules, other options, how to filter the protocols. Yeah.
And further optimize as well, like based on, let's suppose, like if I'm having issue with the HTTP, okay, how we can
Mm-hmm.
optimize our filters.
Yeah.
Yeah,
Create our own filters, something like this. I
correct.
think I created
Yeah.
a filters for that. Usually we get problem with application layer, so I do have filters like this: HTTP response, HTTP errors. Yeah.
Such things. I mean, like, I usually do like that X forwarding, delta time
Okay.
thing, like I have added, but yeah.
What is it? X forwarding?
X forwarding, like if my device, like that front end device is doing the source NAT, okay, if I'm not
Mm-hmm.
actual client IP, I don't know, because it is doing the source NAT. So what it will do, like it will take the IP from the IP header and it will
Mm-hmm.
paste in the X forwarding header of the HTTP. So that,
Mm-hmm.
like, application team should be aware about the client
Okay.
actual IP.
Mm-hmm. Cool. Okay.
I mostly, like, I worked on HTTP, TCP.
Mm. Oh, is it? Okay. So
Praveen,
you work deep level of TCP window size, the
Yeah,
zero windows,
scaling,
scaling.
optimization, then performance
Mm-hmm.
optimization, parameters tuning, such things.
Okay. Cool.
There was a issue like when this TCP buffer was full, like
Mm-hmm.
at the OS layer.
TCP window full.
No, we were having, yeah, kind of, because it was AIX Linux, AIX version flavor of the OS, and at
Mm-hmm.
that time, like we were having 40 gig link, but the
Mm-hmm.
parameters that window size we can compare,
Mm-hmm.
that was configured only 512 KB for the 40 gig link, internet link.
Mm-hmm.
Then we optimize such cases usually happen.
Cool. Nice. We'll have one more session there where you can also talk about in a separate session, maybe in the future.
Yeah, we can.
Yeah.
Been in the view of time where we are seeing the option. Uh, so there was an option where we can see the UTC, right? So it will show the current date and time. So can we select both options, or it's only one can be selected?
Oh no, only one time option you can select at a time.
Okay.
Yeah.
So,
As
Praveen,
I
for
said,
the
it is always recommended to go with delta time or time since previously displayed packet, because we are looking end of the day you're troubleshooting with latencies, so it helps you to figure out your RTT timer.
Okay.
But UTC time, I think it is needed for some users. They may think, okay, in which particular time frame this issue has been happening every day, or maybe there will be a set of time frame where your issues keep happening, right? So maybe you guys are interested to capture the traffic on that particular time frame, isn't it?
Okay. Yeah. Right. Yeah.
Mm. Let
So
let me look into it. I mean, is there an option for the UTC something? I'll check. I have
okay.
to check. But I will always go with Delta time if you ask me. I'll just
Sure.
focus on that. But yeah, this is something I'll look into it. I'll
Okay.
do a research and then come back.
There is an option for the time shift. It is by default, like it is default only, but we can shift the time. Like let's suppose now the captures are at 10:30
Mm-hmm.
DC. We can drift the time, like we can add plus 4:30
Mm-hmm.
in this, and then that will display your current time.
Mm-hmm. Oh, is it?
This is a way.
Okay.
Yeah.
Mm.
Yeah. So you can see like in the view, there is option for the time shift.
Okay.
No, edit in the edit. Edit, sorry. Time shift is there. Control shift.
Here, yeah.
You can click here, shift all packet by minus plus. We can do that.
Mm-hmm. Okay.
Uh,
Cool.
Yeah,
Yeah.
Praveen, actually, today only I joined. I mean, to the WhatsApp group also. If
Mm-hmm.
there is any material shared or any document shared in the WhatsApp, we can resend it. So I'll be able to, or I
Yeah,
can
yeah.
ping
I
you.
didn't send I didn't send anything, but yeah, I will send it today.
Sure. Okay.
Yeah.
Thanks.
Yeah, sure.
So, Praveen, for the lab, is that YouTube video you shared that sufficient, or are you gonna share some other document too?
No, that is more than sufficient. I mean, I will send
Okay.
two files. One is for the PPT and along with the lab files. So you can make use of it and use the video as a reference when you're installing your EventG on your PC. You can follow the steps. Then I think you can do it without any
So
problem.
it's on the site then, right? You upload it on the site, right?
No, I will
So,
send in the WhatsApp group.
oh, WhatsApp group. Okay.
Yeah, yeah.
Sorry, I didn't check that. Yeah.
No problem.
Okay.
There's,
Thanks.
there is, yeah, sure. There's one more link, right? So that's something I have to give for some people. They asked if they don't have a laptop. You can try with this GCP Cloud.
So you send and the Wireshark live batch 6 that, right? That group?
One second.
Uh,
Yeah, what is the question? I think where is the previous chat? Do you guys got one more link which I have shared some time back?
No,
I
no,
think
no, 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 Praveen.
is it? What is it?
Yeah, I have that EVNG that, right?
Yeah. Can you post it again in the chat?
Yes, yeah. Hold on. Let me post.
I think suddenly it disappeared. I don't know why. For the rental labs, you ping me separately. I will give you the number.
I read chat is, I think, disabled.
Is it? Okay, no problem. I will post this in the chat. Yeah. I think it's flipping back and forth. I mean, do you guys see okay. Now I can see the event G. Some just couple of minutes back, I have pasted the GCP link, right? You guys got that?
Is that we got YouTube link, right?
Yeah, you did link for
Yes, it
GCP.
is there.
Yeah.
Yes, it
Okay.
is there.
Suddenly it's not showing up for me. It's okay. It's got it. I think I am doing an option problem here. It's going as a private chat individually. Make it as main chat. Yeah. My bad. I think you should see both links now.
Yes.
Okay, I send you that. You can see.
Okay, so is there any other questions? Any other questions, guys? So we can wrap up the session.
No,
Yeah.
good from my side. Yeah, thank you.
Yeah.